Hello everyone. In this video, we are just going to understand what is meant by blocking code. Let's get started. So this is the same program which we wrote in the previous video where we developed the SysTick driver, and this is the exact 1 second delay, that is 1000 millisecond delay produced by the SysTick timer interrupt. And this one is the LED driver which will turn on the LED and this will turn off the LED. So this is simple blinking process. In addition to these two operations, that is LED on and LED off, I am just going to rewrite this particular blinking process into a new function call. Let's create two more functions above this main. Let's make it light on and light off. In light on, I am just going to put this LED on. Along with that, I am just going to transfer the string lights on along with the enter in the end. Similar to this, I am just going to perform LED off inside the light off function, and here I am just going to pass lights off. Instead of the function LED on, here I am just going to call a light on, and similarly here instead of LED off, I am just going to call lights off. This time what happens here is this function call will turn on the PA5 LED and also it will print a lights on onto the UART bus. And this function, along with turning off the PA5 LED, it will just pass the string lights off onto the UART bus, and intermediate delays will be common. So the same blinking process with exact 1 second delay will be performed here also, except that it will print the strings onto the UART bus additionally. Here it will print lights on and here it will print lights off. I am just going to build this project. Right click on the project and build project. The build is successful with 0 errors and 2 warnings. It is okay. Now I am just going to move to the debug view of the STM32Cube IDE instead of dumping the flash. When you move to the debug view, the flash will be automatically loaded with the new program, and also the debug view starts. So right click on the LED driver. If you give run as STM32C or C++ application, only the program will be loaded to the microcontroller. But when you give this option debug as STM32C or C++ application, the program will be dumped onto the STM32F446RE microcontroller, and also the view of this particular STM32Cube IDE will be switched to debug view for debugging purpose. Let's click on switch. You can see the window is changing its perspective to debug view instead of development view. You can see we have the watch window for watching the variables right over here, and we have a memory window for viewing the memories, register window for viewing the general purpose and all the registers of the microcontroller, and all these debug options can be used in this debug view of the STM32Cube IDE. Now what I am going to do right over here is I am just going to run this program, and in the meanwhile I am just going to open the Docklite software for testing the same software via UART communication. Since we are printing lights on and lights off each and every time after 1 second exactly using a SysTick, I am just going to open the COM port of ST Microelectronics with the baud rate of 115200, and I am just going to run this program. Here also I am just going to run this program. You can see the program is working. It is transmitting lights on and lights off at a regular interval of 1 second. The program is working fine, and now in my nuclear board the LED is also blinking. You can see that. And now when I try to pass this particular program in my microcontroller by clicking on this particular icon right over here, that is suspend icon, you can see the program has been stopped in the 39th line of systic.c, which is exactly inside the delay ms function. Again, I am running the program by clicking on resume button right over here or F8 in my keyboard. Now the program is running. Now when I try to stop this again, you can see the program is stopped in the line number 24 of systic.c, that is inside the getTick function. Again I am starting, again I am stopping. Now also you can see a program has again stopped inside the delay ms function. So this delay ms function is actually the maximum executable function inside our logic. We have 4 different lines in our program: light on function call, delay function call, light off function call, and delay function call. Among all these, delay ms is the maximum executable function, or delay ms actually consumes maximum time in the program. So the program is blocked exactly inside the delay ms function, that is revolving around all these functions, delay ms, and it includes getTick, and also it includes systic handler. This is the interrupt subroutine function for systic handler. So each time it comes inside this function and it increments the g current tick variable and it goes out. So maximum time is blocked inside this systic functions and not in the real time function lights on and lights off, or not in the application functions lights on and lights off. So 90% of time of the program is blocked inside the delay function, and this method of executing the code is called blocking code. So it actually blocks the application code from running. So this is not an advisory manner. So we have 2 different threads basically in this program. One is the foreground thread, which runs the lights on and lights off inside the main function, and the background thread is nothing but the interrupt subroutine function right over here. So this runs maximum, this consumes maximum time, and the application software actually consumes less time. So this is not advisable, and it may cause serious issues if it is a safety relevant application. So this is not advisory for using in a safety relevant product. And remember, if you are having a serious sensor safety check right over here, and while processing the maximum time in this delay function, we got a particular sensor warning, safety warning, and the code is blocked right over here. Once the code is released from this particular delay function, it comes to this application software, and this application software actually detects the safety issue after 1 or 2 seconds. That may cause a serious issue in your application or to the operator who is operating your product. So that is why in safety related applications, we instead use a parallel execution method instead of blocking code method. So this blocking code method is well suitable, or it is suitable for a simple application like timer, counter, etc. But for serious safety related products, you cannot use this. It may cause serious issues to the product and also for the operator who is operating your product, or the person who is operating your product. So try to understand, this is the blocking code software which blocks the program time, maximum program time inside a particular function or inside a particular module of the function using ISRs or even using a loops. I hope you understood what is blocking code in this particular video, and where you can use the blocking code, and also why we are not supposed to use the blocking code in this particular video. See you in the next video. Thanks for watching.